Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a continuation on the lecture video on chapter of induction machines. Okay, so my name is Dr. Nur Zulaili binti Muhammad. Here is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Okay, so in this video, the subtopics that we are going to cover includes operation principles of the induction machine and as well as three modes operation of the induction machines. Okay, so now let's move to the first subtopics, which is operation principles of the induction machines. Okay, so the operation principles of the three-phase induction machine can be described as per this animated diagram. Okay, so basically the red color, this red color represent the stator winding. Okay, so this is the magnetic field. So this we call as a rotating magnetic field. Okay, so the silver one at the middle is the rotor. Okay, so the blue color is the induced current that flow through the rotor. Alright. Okay, so how does the induction machine operates is actually started by this. Okay, so we have a stator. So the red color is the stator winding. So the stator is initially supplied by the three-phase voltage. Okay, so the three-phase voltage that supply to the starter will cause the three-phase balance current to flow through the winding. Okay, so once you apply the voltage to the stator winding, then it will cause the current to flow. Okay, so next, once you have the current flow, it will generate the rotating magnetic field. Okay, so because of the current that flow through the winding, so it will cause this magnetic rotating field. Okay, rotating magnetic field. Alright. And then the field will rotate at the synchronous speed. Okay, so the synchronous speed is determined by the frequency of the supply voltage and the number of poles. So the formula is given by 120 multiplied with the frequency of the supply voltage divided by the number of the pole divided by P. So the unit of the synchronous speed we call as a RPM, rotates per minute. Okay. And then the rotating field, okay, so this rotating field will induce a voltage in the short circuit rotor conductor. So once the rotating field is rotate across the rotor, so it will induce the voltage through the short circuit rotor conductor. Okay, and then the induced voltage will generate the current in the bar. So the blue color represent the current in the bar. Okay, so the interaction between the rotor current, the blue color, and the stator field, okay, so this is the stator field. The interaction between the rotor current and the stator field will produce a force that drive the motor. So that's why you see the silver rotor will be rotate. Okay, so the rotation is due to the interaction between the current, the blue color, with the rotating magnetic field. So that's why the machine we call as a induction machine, because the AC current is supplied directly to the stator, but the AC current is connected to the rotor winding by induction based on the interaction between the rotor current, the blue one, with the rotating stator field. Alright, okay. Okay, so for summarization, the operation principles of the induction machine can also be represented by this flowchart. Okay, so firstly, you have a rotating flux in stator winding and also a rotor winding. Okay, so you have a rotating flux in the stator and also in the rotor. Okay, so this will cause the induced voltage in the rotor. Okay, and then based on the induced voltage, it will cause the current to be generated in the rotor. So that's why you have a current, the one with the blue color. Okay, so once you have a current, the interaction between the rotor current and also the stator field, okay, the blue one and with the rotating magnetic field, it will cause the force that drives the motor. Okay, so that's why you can see the movement of the rotor. Okay. And then finally, the torque is developed. Alright, so this is how the induction machines works. Okay, next, the magnitude of the induced voltage in the rotor is actually depends on the speed difference between the rotating stator field and also the rotor itself. So the speed difference we call as a slip. Okay, so the speed difference is actually maximum during the startup of the motor. So when you try to start the motor will draw the large current of the large amount of current at this time, and the speed difference is maximum. Okay, so when the motor starts to rotate, the speed difference will be slowly reduced, and then consequently it will also cause a reduction in the induced voltage in the rotor, as well as a reduction in the magnitude of the rotor current that flow in the rotor. Next, if the rotor speed is equal to the angular speed of the stator field, okay, so when the NR is equal to the NS, the induced voltage, the current, and also the torque will become zero. So that's why we must make sure the motor speed, which is NR, must be less than the synchronous speed. Synchronous speed is the speed of the stator field. Okay, so NR must be less than synchronous speed. It cannot be equal, because when it is equal, the induced voltage, the induced current, as well as the torque will become zero. Okay, so the motor operation requires speed difference between the stator generated rotating field and also the actual rotor speed. So the speed difference we call as a slip. Okay, so the slip is defined by this equation, where S, slip, is equal to Ns minus Nr divided by Ns. So Ns represent the synchronous speed, which is the speed of the rotating magnetic field by the stator. Okay, so Nr represent the rotor speed. Okay. Alright, so your Ns is given by 120 multiplied with the F, frequency of the induced voltage, frequency of the supply voltage, divided by P. P is the number of pole. Okay, so basically the slip value in normal operation is between 1 to 5%. Okay, next we go to the subchapter of modes of operation of the induction machines. Okay, so basically there are three modes of operation that available for the induction machines. Induction machines can be operated in three modes. Okay, so first thing, it can be operated as a motoring operation, generating operation, and the last one is the plugging operation, or we can also call it as a braking operation. Okay, so in the motoring operation, the rotor is actually rotates in the same direction as the stator magnetic field. Okay, so meaning that the NR direction is equal to the direction of the NS. Okay, in the generating modes of operation, the rotating at speeds higher than the magnetic field. Okay, meaning that the NR is larger than NS. Okay, so we can call it also as a regenerative braking. In the plugging mode of operation, or we can call it as a braking operation, the rotating is in opposite direction of the magnetic field. Okay, meaning that the direction of the NR is opposite as per NS. Okay, alright. We can also summarize the three modes of operation based on this graph. Okay, so you see the first cycle, we call it as a braking region. Okay, so the second one, the middle part, we represent as the motor region. Okay, so this is the generator region. Okay, so based on the graph is actually represent the speed of the rotor. Okay, so the rotor speed across the torque developed. Okay, so for the x-axis, you can see this is represent the speed in the percentage of the synchronous speed. Okay, so where it means that this is 0% of the synchronous speed. Okay, so this is the 100% of the synchronous speed. So meaning that at this point, the value of the speed is equal to the NS. NS is the synchronous speed, or we can call it as a speed of the rotating magnetic field. Okay, and then the x-axis can also represent by the slip as a fraction of the synchronous speed. So you can see that when the speed of the NS is equal to 0, so meaning that the slip S is equal to 1. Okay, so when the speed is negative percent, so meaning that the value of the slip is higher than 1. Okay, alright. So for the y-axis represent the top value. So from this point to this point represent the positive top, and from here to here represent the negative top. Okay, so in the braking region, for the first cycle here, for the braking region, in this situation, the speed of the motor, the speed of the rotor, which is NR, is less than 0. Okay, less than 0. Okay, 0 meaning that 0% of the NS. Okay, it is less than 0, and the torque is positive value. So in this cycle, the speed also negative. Okay, alright. When in the motoring region here, in the motoring region, the NR, meaning that the rotor speed is larger than 0 but less than NS. Okay, during this region is larger than 0 but less than the NS value. And then in this region, the torque also positive, and the speed is have a same direction as per synchronous speed. Okay, alright. And then in the generating region, the value of the NR, the rotor speed, is larger than the synchronous speed. Okay, so in this one, in this condition, the torque is negative. Okay, you have a negative torque, and also the speed is positive. Okay, so there is only one speed where the induction motor does not develop any torque, which is, we call it as a synchronous speed. Okay, so if you refer to this graph, okay, so in this condition, when the NS is equal to NR at this point, the torque value is 0. Okay, so torque is 0 when NS is equal to NR. So there is only one speed when the NR is equal to synchronous speed, so the induction motor does not develop any torque. So this is because the rotor conductors are not moving relative to the stator field. Consequently, there is no voltage, no current will be induced in them at this speed. So that's why we must make sure the NR must be less than the NS in order to make it become motor, okay? Or the NR must be larger than the NS in order for the induction machine to be acting as a generator. It cannot be equal, because when it is equal, there will be no voltage induced and there will be no current induced in the machine. Okay, so the torque always act in the direction to move the speed towards the synchronous. Okay, so usually you have a positive speed below the synchronous speed is motoring operation, meaning that when your NR is positive and then the NR is less than NS, so it is in the motoring operation mode. Okay, so next, if the NR is a positive value and it is larger than the NS, so it will be acting as a generator operation mode. Okay, if the NR is a negative speed, okay, so it acting as a brake. Alright, so that's all for now. Thank you for your time. Thank you for watching my video. We will continue on our topics on the equivalent circuit of the induction machine in the next following video. So bye for now. I'll see you in my next video. Okay, bye.